Okay, welcome again, grade nines. Welcome back to another instruction videos from Mr. D's math class. This time we're actually going to go into calculation with scientific notations, which is actually your next assignment. So no way to show you this but by example. Let's do calculations with big numbers first, and that's what scientific notation is about. It's about the really big numbers or really small numbers. And if you've already been in class today, you know that usually really big numbers are used for astronomical measurements, like in astronomy or measuring distance from planets, even to stars, which is measured actually in light years. And then small numbers are usually measurements in the microscopic world. Okay, so we'll do the big numbers first. First, we're going to give you an example on multiplying with big numbers. Okay, in scientific notation. Um, but first, for a number to be in scientific notation, um, it has to have a decimal with a ones place and a tenth place, and then it has to be multiplied by um, a base 10 to an exponent. Well, actually, you can have as many exponents, or pardon me, you can have as many decimal places after this tenth, but it's the preferred format is or format or text is usually just one decimal place, but you can probably hold two or three here if you wanted to, but one actually makes more sense as long as the decimal only holds a ones place and then followed by a tenth or a hundredths. But this definitely has to have a ones place here. So now I've got here is 2.5 times 10 to the 13, and I'm going to multiply that with 4.7 times 10 to the 8. Okay, and so to do this, really all you're going to have to do is you start off with just multiplying decimals first. It's 2.5 times 4.7. And so we're going to get a decimal for that, but that decimal also has to be multiplied by the base 10s. So in this case, you're going to multiply the base 10s as well. 10 to the 13 times 10 to the 8. And so when we do this in our calculations, 2.5 times 4.7 is actually 11.75. And the base 10s, this is why I did this after exponents laws. So this is a product law. When you have powers of the same base, you simply add their exponents, 13 plus 8. Okay, just 21. So now we have 11.75 times 10 to the 21. Well, unfortunately, this is not finished yet because this 11.75 cannot be kept as a decimal like this. Okay, scientific notation, this decimal has to be in between these ones. Okay, so what we're going to do is we're going to turn this 11.75 by itself into a scientific notation. In the scientific notation, that'll be 1.175. And you see, notice I included 3 decimal places after this, and you can actually do that. So 11.75 as a scientific notation by itself is actually 1.175 times 10 to the 1. Okay, and that's still being multiplied by 10 to the 21. So together, now you add the exponents for these two, for these base 10s. So you can have 1.175 times 10 to the 22. And this is our final answer. Okay. Now let's try division with really big numbers. For example, 1.8 times 10 to the 15 divided by 3.9 times 10 to the 8. Okay, it starts off almost exactly the same as the first example, where you do the division between the decimals first. Here, 1.8 divided by 3.9. Okay, and that decimal is still being multiplied, or has to be multiplied by base 10. So this, now we're going to divide the base 10s, 10 to the 15 divided by 10 to the 8. Okay, and on a calculator, 1.8 divided by 3.9 is 0.46, followed by a bunch of other digits, but I'm going to stop here 0.46. And that's being multiplied by, and now this is the product, pardon me, this is the quotient law. So when you're dividing powers of the same base, you subtract their exponents. 15 minus 8 is 7. Okay? But again, unfortunately, we are not done here yet because this is not quite a scientific notation, as the decimal is not in between the 4 and the 6, and it has to be. It has to have a decimal that has a ones place. And so how do you turn this itself into scientific notation? Well, this has to be 4.6 times 10 to the, when I'm moving the decimal here, this 4 is actually a 10th place. So as an exponent to the power of 10, or the base 10, pardon me, this actually has to have an exponent of negative 1, okay, times 10 to the 7. Okay, so here again, we have to add these exponents. Negative 1 plus 7, which is 4.6 times 10 to the 6. Okay, and just to let you know where this 10 to the negative 1 came from, well, this actually, if this was a 1, this 0.1 is actually equal to 1 over 10. Okay, and as an exponent, if you wanted to rewrite this as a positive exponent, as a power, this is actually 10 to the negative 1. And really, that's what negative exponents are really all about. Okay, I'm also going to upload an explanation of what negative exponents are, but technically this is what that is. Okay, 10 to the negative 1 is equal to 0.1. Okay, and because this 4 was in the 10th place, well then that'll actually be 4 times 10 to the negative 1. Okay, that's what 0.4 is going to be. 4 times 10 to the negative 1. Okay, that's it for the big numbers. So I think in a separate video, I think we're going to do the multiplying and dividing of really small numbers, scientific notations of really small numbers. So that's for the big numbers. Hopefully, we'll see you for the viewing of the really small numbers.